bit underrated. So I think they have two fixable disadvantages and one very, very strong advantage. The fixable disadvantage is that they're pretty low-level devices. So I think of, colored coins, it's what they're called as like, the assembly languages of smart contracts. And so, many programmers don't want to or can't use assembly languages, and so that hinders their adoption a little bit. The other problem is that they're not so expressive, right? So pretty much every colored coin protocol comes with a fixed set of transfer types built in, and that severely limits the kinds of applications that you want to build. And if a developer wants to develop a new application on a colored coin protocol, they usually need to talk to the protocol devs, and that's kind of a slow process. But they do have one big advantage, and that's their scalability, right? And so in particular, if you use a colored coins protocol, you're not putting any load on the miners, right? So miners don't have to run additional code, not putting any load on the other users. So that makes them, very, very cheap to run at scale, okay? And so, this was, somewhat, subjective classification of smart contract system, but there's also much more objective ways to look at this topic, right? So in this picture over here, you can see sort of the results of many decades of research in computer science in the field of complexity theory. And so what you can think of, every dot in this plane here represents one program, right? And then we draw a little box around, programs that have sort of similar, resource requirements, right? So down here in this box called finite, you can see programs that only need very, very small amounts of memory and very few computational steps. And these bigger enclosing boxes, tend to be algorithms that take very, very many computational steps, take a long time to terminate, right? And sort of now, this is a different way that we can classify these smart contract systems. And so, these colored coins, they really sort of only can express a handful of programs, and they mostly sit down here in this very, very efficient class of algorithms. Sort of the other basic approach to smart contracts is called miner-validated smart contracts, pioneered by Ethereum. And sort of their idea to fix the shortcomings of the smart contracts on UTXO-based blockchains is to, have miners execute the code. And the advantage is that this made it much, much easier to program smart contracts. And so all of a sudden, and the reason is that people can use higher level languages similar to JavaScript to program these smart contracts, and many, many more developers were able to write them. And so, they took off massively, right? And then sort of the second point is even more impressive, right? So while I kind of said that all of the colored coins kind of live down here in these, very restricted, algorithm classes, Ethereum claimed that they can do any computable program could be run within Ethereum, right? And sort of that would obviously be a massive breakthrough, and we could literally rebuild the entire tech industry based on smart contracts, right? However, everybody who's ever used Ethereum knows that knows about the third point about the problem. They're not scalable, right? So it's very, very expensive to use smart contracts, and in particular, you have to pay, since the miners evaluate the smart contracts, you have to pay them to do that work. And so the cost model for smart contracts on Ethereum is you have to pay for every single computational step, right? And so now, if we actually go back to the second point, there's an interaction between these last 2 points, right? Because there's an underlying assumption when you say that every program can be run, and the assumption is that someone needs to have infinite funds, because someone needs to pay for all this computation that gets replicated on every single miner, every single validator. So if we make a more realistic assumption that there's only finitely many funds, then we can actually say that instead of being able to run every program, we can only run programs that do, not so many steps, right? And sort of, the more formal way of doing it is say you can do logarithmically many steps in the size of the program, right? Otherwise, you would build applications that, once they, gain more users, the price for using them goes up, right? And nobody would like to use a social network where the price of using it goes up by 10x just because it had 10x more users. So with this more, realistic assumption, we can actually see that instead of being able to run all smart contracts on Ethereum, we can only run the ones that use very few computational steps. And sort of that is my explanation for why everything in Web3 is so weird and so different from what we usually use on our devices. And it's because of these restrictions that it's too expensive to use them. And so on this picture, you could say that essentially Web 2 lives in this much, much bigger box of algorithms, much more interesting algorithms called polynomial time, whereas Web 3 is restricted to these very, very tiny algorithms that can only do very few steps. Okay, so summing up the trade-off that we face as an industry, you can either use user-validated smart contracts, and the disadvantages are they're not so easy to write, and there's you're pretty restricted in the kinds of programs you can use, but they're very, very cheap to run at scale. Or you can use a miner-validated contract, so it's easy for programmers to produce. But the problem is they're very expensive to run, and the expressive power is sort of debatable, right? And so obviously, the question arises, can we get the best of both worlds, right? And so now, if the answer were no, that would be the worst setup of our talk ever. Luckily, the answer is yes. And so that's kind of what we're presenting here today, our new smart contract system that sort of checks all 3 boxes. They're very simple to write to the programmer. You can actually, not just in theory, but you can run all smart contracts, any program as a smart contract, and you can do it at a very low cost. Okay, so let me tell a little about it. It's called the Bitcoin computer. It's a general smart contract system for Litecoin and Bitcoin. It's very easy to use. So smart contracts can be written in JavaScript. So I'm not going to bore you and walk you through this code, but this is very simple to read TypeScript code in this case. And so any programmer that's built a website will be able to understand this code and produce smart contracts written in TypeScript or JavaScript. They're very expressive, right? So now we can actually, I'm again going to claim, like they did before, that we can run any algorithm in as a smart contract. And so this is without making the assumption that somebody has infinite funds, because of this property, because of specifically this third property that you're not asking the miners to do any work for you. And so for that reason, you can run arbitrary programs of arbitrary complexity at a fixed cost, right? And so, I mean, obviously there's not enough time here to actually explain to you how it works, but I want to sort of give you, broad intuition for what, the obstacles were that we had to overcome to sort of essentially unleash colored coins. And there's 2 things you need to do. You need to be able to express any possible data type, right? And the second thing is you need to be able to update any possible data type in any computable way, right? So the first piece is actually not very surprising. So colored coins typically already, support basic data types like, strings and numbers. And normal programming languages also use these structured types built up from arrays, objects, and basic data types really. And so you have to find a way to encode this in the UTXO model. That's not actually very hard, and the reason is that we can, today's computers store these complex data types in these very simple, main memory arrays. That's just like a linear array. So you just pick yourself a textbook, and you can actually quite quickly figure out how you can encode every possible data type on top of UTXO-based blockchains. Right? And sort of the second step is kind of the step that's hard. And here the intuition is that like programming languages aren't built up from like an infinite number of constructs, right? Every programming language is just built up from a handful of constructs, right? We have a few kind of loops, we have if them else, we have assignments, right? And the point of programming language is that these basic constructs are cleverly designed so that they can be composed to express any possible program, right? And sort of now, we can take this as inspiration for how to design colored coin protocols. Is essentially the basic transfer types of a colored coin would correspond to the basic syntactic constructs of a language, and if you define these basic transfer types correctly, then you can recombine them to essentially compute any possible update. And sort of the third trick that's required to make it all work is essentially you have to give more power to the programmer, right? So instead of us as protocol developers deciding precisely which transfer types can exist, we're essentially allowing the programmer to define novel transfer types on their own without needing to talk to us. And we also don't need to invent a new formalism for that, because we have these fantastic formalisms called programming languages that the programmers can use to define their transfer types. So a little bit about the system that we're building. Has 2 main components, the server-side node and the client-side library. The server-side node is required to provide trustless access to the blockchain. So it runs, a Litecoin node developed by the Litecoin Foundation. It also sort of creates a wallet to compute all the user balances. That makes it much easier to build applications. And we've done a lot of work to make use of modern computer hardware so that the sync process that can take many weeks or many months. If we can make use of all the many cores that today's processors have, we can vastly speed up the time to sync. And overall, we think our node just makes it very easy to run a node, to use rec test, and the idea is to provide a great developer experience, regardless if you want to build an application for the Bitcoin computer or just any other Litecoin application. And sort of most of the heavy lifting is done by the Bitcoin computer library. Sort of the main functionality is to sort of encode all these data structures and all these data updates that I talked about before in Litecoin transaction and broadcast them to the blockchain. And then the other functionality is to sort of read the inverse operation where you kind of read the transaction from the blockchain and parse them into the value over which the user wants consensus, right? So the point of a smart contract is 2 people play a game and they want complete consensus of what is the state of this game or what is the state of the application. So that's kind of the second functionality that the Bitcoin computer provides. So then the next 2 points sort of arise naturally out of our approach. And they actually add something to programming languages that doesn't normally exist. So a very natural way of data ownership emerges, where just like if you own a Satoshi, you're the only person to decide when and where that Satoshi gets spent. So if you own a piece of data, you're the only person who gets to decide when and how the data can be updated, right? And so that's one property we add to programming languages. The other property we add, that it's sort of, if you store data on the blockchain, you get access to storing cryptocurrency and data in one atomic unit. So that's also something that's usually not possible in programming languages, but it's possible if you run them in a colored coin. We have two more. So I've heard a lot of talk about privacy today, and privacy is obviously also important to us, just philosophically, but also we work with big companies and they need to comply with privacy laws, GDPR and consumer protection laws in California. And so for these reasons, there are certain features that need to be built in. Very strong encryption. So our encryption has two layers of AES and asymmetric encryption. And we have a off-chain solution that makes it very easy for the programmers to designate which data is to be stored on the blockchain and which is stored off-chain, right? And it's at different reasons, some legal reasons, but also we obviously need to prevent blockchain bloat, not to put too much data on the chain. And one feature that we've added recently is, standard compliance ES6 modules. That's essentially just a feature that allows people to break down these very, large, complex programs into smaller, much more manageable blocks. So now I would like to invite Laura to the stage. Laura is going to, so we had a demo prepared, but for technical reason, we couldn't connect our laptops in the way, so we turned our demo into slides, but you can follow Laura's steps, and she will show you how you can start a decentralized application on top of the Bitcoin computer. Everybody give it up for Laura.
Thank you.
There you go.
Thank you. Well, good morning. I want to show you how easy it is to launch a decentralized application on Litecoin using the Bitcoin computer. So first, what I want to explain is I'm going to get started with our monorepo on GitHub. So in this monorepo README file, you're going to have all the documentation that you need for use in our smart contract system. In particular, we have the documentation of how to run a node, a Litecoin node. So let's get started with that point. For launching a decentralized application, what we need to do? We need to launch a Bitcoin computer node, and then we need to launch our web application. So it's very easy. What you need to do first is to install all the software needed for launch a Bitcoin computer node. So first you have to clone our monorepository, and we provide several scripts. Well, the Bitcoin computer node runs through Docker, so if you don't have Docker installed, what you have to do is to run some scripts to set up all your machine. And then it's very easy to run a node. What you need to do is to run only one single command, that is yarn up, right? Well, we prepare here like a screenshot that you can run this on your terminal, and once that the node is up and running, the only thing that you need to do is to launch your web application. One important feature that we need to highlight is that you can synchronize on testnet and on mainnet your node in parallel, so you can exploit the functionality or the underlying architecture when syncing to testnet or mainnet. And we prepare here a graph with time and cost estimation. You can see clearly that if you scale the number of CPUs, you can reduce the synchronization time up to 5x. Okay, so once that we run the node, the Bitcoin computer node, what we need to do is to run the application. You can use our open source project. We have a non-fungible token application, and it's also very easy to install. Yarn install is one of the commands to install all the dependencies, and once this is done, you run with yarn start the application. So we prepare here a screenshot of our application. That is a Litecoin art application. So here you can see that we have your artwork, so you can create a new artwork and send your NFT to a friend. For that purpose, we need to provide the public key of the receiver. And also we integrate here a wallet with the balance calculator. You can calculate or query your balance, and you have your address and public key. So it's very simple. With these two simple steps, you can run a Bitcoin computer node. By default, it will run on Litecoin Rectest, but you can provide several parameters. You can play around with our configuration. and with our open source project. So we invite all of you to try with our repository. Thank you. I will invite Clemens again to finish the presentation. Thank you.
Okay, so we're almost done. I just want to quickly. Okay, so just one more slide in conclusion. So what's new here is, I think for the first time, we can actually run all algorithms as smart contracts, right? And in my opinion, this opens up lots of new capabilities, just new applications that can be built on Bitcoin that could have never been built before. And different things come to mind. Social networks where users are actually in control of their funds and where they have perfect data mobility, but also social networks that guarantee properties to the users, right? So there's the suspicion that, for example, a social network might use different algorithms to produce a feed for different users, right? And smart contracts are a tool for operators to guarantee properties of their service to their users. Another application that just cannot be ever built on Ethereum is, for example, Uber. Right? Uber requires some computation essentially to compute how far do you want to go, how much do you have to pay. It takes n squared, so many computational steps. If you wanted to run that on Ethereum, it would probably cost $100,000, no exaggeration, because in the size of the map, $100,000 just to order the cab. So that will never be built on Ethereum. And you need something where you don't pay per computational step and you have a fixed cost. Right? Games is another application. There's websites where millions of people play chess on the internet. There's very few websites where you can play chess for money. It will be something that will be pretty easy to build on top of the Bitcoin computer. But then, once you can build chess, computation doesn't cost anything. Right? You might as well build a beautifully 3D rendered car racing game where you and your friends could race on the internet for money, for example. And then, AI is about sort of to take over our lives. And I think it will actually be quite scary. And I think, blockchain and smart contracts are one way to tame AI, to give the user some guarantee for what this AI algorithm actually does. So, so the idea would be to fulfill the promise of smart contracts finally. And that's the end of my talk. Thank you very much.